Hello, thank you for checking out Mr. Ware's videos, and today we're looking at how to write and interpret functions. Write and interpret functions. So what we're going to do today is take a look at some word problems, interpret and find which one is independent and which one is dependent. Write the function and solve for a given independent. Okay, so I'm going to try to make that a little bit more clear. But remember in some previous notes that I gave you that the independent is for the X and the dependent is for the Y. And what you want to do is interpret it within the given context and say which one of these two things is dependent. Okay, and they'll give you choices so you can solve it. Okay, so let me show you an example. Okay, so a lot of this is already filled out for you, so I can be able to write on here like I want to, but I'm going to show you exactly what they're doing here. Okay, so it says Isaiah had 6 inches of snow on his lawn, and it began to snow at a rate of 2 inches per hour. Assume no snow melted. Answer the questions below regarding the relationship between the number of hours and the snow being falling on the ground. Okay, those are your two. Which one's an X, one's a Y, which one is which? Well, you determine it by which one's dependent. Okay, so and I'm just going to read it and it'll make sense. The independent variable X represents the hours since the snow started, and the dependent variable is the inches of snow on the ground, because the inches of snow on the ground depends on how many hours it's been. So you find out which one is dependent and the other one is the independent one. You can't figure out how much snow is on the ground unless you know how many hours it's been snowing. Okay, so now that's that first part. The next part is we got to write the function. Okay, so I'm going to start where we begin. We begin with 6 inches. All right, and we're going to add 2 inches every hour. So I'm going to add 2 inches, and I'm going to use a variable to represent the hours. And since they want us to use this function notation, I'm just going to use X. So that's it. This 6 plus 2X goes here. That's the function. Now they give us, D of 5. Well, what does that mean? They don't tell you it's hours, but since we already determined that the X is hours, it's 5 hours. So if we plug in 5 hours here, what will we get? Okay, so 5 times 2 would be 10. 6 plus 10 is 16. So D of 5 is equal to 16. So if we plug in, which means the hours of snow, after 5 hours of snow, there will be 16 inches of snow on the ground. All right, go ahead and pause the video and see if you can solve this one. Okay, so this should be what you get. You begin with 1 inch of snow, and it's growing at a rate of 2.5 inches per hour. And it's the exact same question, so the independent dependent should be hard. But the independent is the hours since the snow started, and the dependent is the amount of snow on the ground. And then you plug in 5 here, solve, and get 13.5 inches of snow after 5 hours. And there you go. All right, so let's take a look at another example. All right, Ari is driving along at a highway at a speed of 50 miles per hour. Answer the questions below regarding the relationship between distance and time. So they left you with a little less words on this one, but that's because there's less stuff to do here. So here we got distance and time, and we're trying to figure out which one is dependent on which one. Well, If you've been driving for, you need to know how many hours you've been driving, figure out how far you've been. So the time is independent and the distance is dependent. So that's why you get the independent variable x represents the number of hours driven, and the dependent variable is the number of miles traveled. Because the number of miles traveled depends on the number of, oh, this is wrong. The number of miles traveled is dependent upon the number of hours driven. That's a mess up. Okay. Okay, so this should be here. All right, now, so I'm gonna erase that here, and we're gonna solve it from here on. Now, here's the deal. All they give you is 50 miles per hour, and that's it. So it's just one number. It seems difficult, but it's okay. So what do you begin with? Well, they don't give you anything to begin with, so you begin at 0. You can write the 0 and then add the 50, right? Add the 50 times whatever number of hours you've driven. Or you could just say 50 times the number of hours driven. See how that works? All right. So that's the function, just 50x. Because you begin at 0. There's nothing to add on to it there. So then next they tell us, okay, 3 hours, how far have we went? Okay. So we're gonna plug in 3, 50 times 3, and get 150. So after 3 hours driven, you've been 150 miles. All right, I'm gonna go ahead and pause the video here and see if you can solve this one. Okay, so this should be what you get. Okay, so on a test, you would know, usually you don't get any points at the beginning of a test. So you start off with 0. Okay, and every question you get right, you get an extra 6 points. Okay, so if you got 13 right, you get your score up to a 78. And the number of whatever your score is on the test is dependent upon the number of questions you get right. All right, let's take a look at one more type here. All right. Okay, so Chloe bought a bag containing 65 small candies. She starts eating the candies at a rate of 5 candies per minute. Answer the question below regarding the relationship between the number of minutes eating and the number of candies left in the bag. So she's going through this candy, 5 candies per minute. They want to know what's happening. So you start off with 65. Now this is different than the other problems because instead of going up, you go down. So you'll need to subtract. But the number of candies in the bag is dependent upon how many minutes has gone by where she's tearing through all these candies. So that's why I got set up here. I think I got it right this time. All right. Yeah. So the number of minutes eating and the number of candies left in the bag, blase, blase. Now, so let's set up the function. So the function is going to begin with 65, right? And instead of adding, we're going to subtract. Okay, and how much are we subtracting? We're subtracting 5. Okay, 5. And we're going to multiply that by the number of minutes it's been. Okay, and we don't know what that is, so we put x to represent it. So that's our function, 65 minus 5x. Okay. Then they give us n of 9. So 9 is the number of minutes has gone by. It's the independent variable there. We're going to plug in 9 to figure out how much candy is in the bag after 9 minutes. Okay, so we do the 5 times 9 to get 45. 65 minus 45 is 20. So it's 20 candies left in the bag. So that means after eating candies for 9 minutes, there will be 20 candies left. That's a lot of candy in 9 minutes. But, okay. All right, now take a look at this last example and see if you can solve this one. Okay, so this should be what you get here. You should get 5.5 gallons left in the tank here. So you start off with 13 gallons and you're going down 2.5 gallons per hour. So that's how that works. The amount of gas remaining is dependent upon the hours. And just a little heads up, not 100% of the time, but more often than not, the time is going to be your independent, your X, your input on most of these word problems. So be aware of that. It's not 100%. It's possible to flip it on you, but more often than not, the time element is going to be the independent. Okay, so keep that in mind. But that is how we write and interpret functions. I want to thank you for checking out Mr. Ware's videos. Have a nice day.